Welcome, everyone. Today, we're going to dive into the essential principles of foodborne diseases. Whether your path leads you to public health, the culinary world, or medicine, a really solid grasp of food safety is, well, it's non-negotiable. So let's jump right in. Here's our plan for today's lecture. We're going to start by defining what a foodborne disease is exactly. Then, and this is important, we'll distinguish between its two primary classifications. We'll look at a real-world case study for each, and then we'll pull it all together by looking at the core principles of prevention. Okay, first things first. Before we can even begin to talk about controlling these illnesses, we have to establish a clear, precise definition. We need to be on the same page about what we're actually talking about. So, here it is. A foodborne disease is an acute illness. That means it usually comes on pretty quickly. It's linked directly to eating food that's been contaminated with something harmful, either a living pathogen or a chemical toxicant. And here's the crucial part. There has to be a sufficient amount of that contaminant to actually cause sickness. A tiny bit might not do anything. It's all about the dose. Now we're getting to the most critical concept you need to grasp today. Every foodborne disease falls into one of two categories. The distinction between them is absolutely fundamental to understanding how these illnesses work, from diagnosis all the way to control measures. So first, we have the foodborne infection. The best way to think about this is like a tiny invasion. You eat food containing living, pathogenic microorganisms. Those microbes enter your body, find a nice spot, and start to multiply. It's this colonization, the microbes literally setting up camp inside you, that causes the illness. On the flip side, we have foodborne intoxication. This is basically a poisoning. Here, the illness is caused by a toxin that was already present in the food when you ate it. The microorganism that produced the toxin could be long dead and gone. What matters is the poison it left behind.
And this table perfectly illustrates the difference. For an infection, because the microbes need time to multiply inside you, the incubation period is longer. We're talking days. That biological process often triggers a fever as your immune system fights back. With an intoxication, though, the toxin is preformed. It gets to work right away. So the onset is incredibly short, minutes to hours, and a fever is pretty rare.
Okay, theory is great, but let's make this real. We're going to examine a classic case of a foodborne infection, salmonellosis. Salmonellosis is just a textbook example. It's caused by the Salmonella bacterium, and it's not just one thing. It's a massive family with more than 2,000 different varieties, or serotypes. These bacteria are literally everywhere in our environment, commonly residing in the guts of animals and people. Now, this is a really interesting point. To actually get sick from salmonella, you typically need to ingest a very high dose of the bacteria, somewhere between 10,000 and 1,000,000 organisms per gram of food. This tells us something vital. It's not just about a food being contaminated. It's about the food being handled in a way that allows those few bacteria to multiply into a massive army.
So how does that happen? Well, the contamination can occur through multiple pathways. It might happen at the processing plant during slaughter. It could be transferred by a food handler who didn't wash their hands, or it could even be carried by pests like flies and rats in the kitchen environment.
Logically, then, our control measures are all about breaking these chains of transmission. We focus on hygienic handling to prevent contamination in the first place, and then we rely on proper cooking and heat processing to kill any bacteria that might have made it through. And of course, complete thawing is critical because heat can't kill what it can't reach in a frozen center.
All right, let's move to our second case study. This is going to build a really contrasting picture because now we're looking at a foodborne intoxication. Botulism. So botulism, it is a rare disease, but it is extremely dangerous. And again, let's be clear, you don't get sick from the Clostridium botulinum bacteria infecting you. You get sick by consuming the incredibly potent toxin that it produces when it's allowed to grow in an oxygen-free environment, like an improperly canned jar of food. And here's the scary part. Unlike salmonella, which primarily causes a gut infection, the botulin loxonin is a neurotoxin. That means it bypasses your digestive system and goes straight for your nervous system, directly interfering with nerve function. And to underscore just how serious this is, the botulinum toxin is recognized as one of the most lethal poisons known to humanity. We're talking about a substance so potent that a microscopic amount can be fatal. The symptoms directly reflect this attack on the nervous system. You see nerve paralysis, muscle weakness, double vision, And eventually, it can lead to respiratory failure as the muscles that control breathing become paralyzed. You can see why the mortality rate is so incredibly high without aggressive medical treatment.
Prevention, therefore, is absolutely paramount. It centers on proper sterilization practices and canning to destroy the bacteria's spores so they can't grow and produce the toxin. And on a practical level, it means rejecting any spoiled or damaged canned goods. But there's a final safety net. The toxin itself, luckily, is destroyed by heat. Heating food to 80 degrees Celsius for 10 minutes will destroy the neurotoxin.
Okay, so we've looked at an infection and an intoxication, two very different mechanisms. Let's now synthesize all of this and lay out a set of unifying principles for food safety. These are the fundamentals. They apply broadly, whether you're trying to prevent an infection or an intoxication. Good personal hygiene, proper cooking, avoiding cross-contamination, keeping food at safe temperatures to inhibit microbial growth, using safe ingredients. These are the pillars of food safety in any setting, from your kitchen at home to an industrial food plant.
So I'll leave you with this final thought to consider. Our food system is more global and more complex than ever before. As we look to the future, which challenge do you think is greater? The risk of fast-acting toxins in highly processed foods, or the threat of slow-developing infections that can travel silently across continents in a matter of days? It's something for us all to think about. Thank you.